For example 2, you need to know that the product property of roots means that if your index is the same, so if that little number on the shelf is the same, then you can multiply the radicand, the number inside, or if the quotient property roots, if the index is the same, then you can divide the radicand. So if we come over here, so simplify each expression. Okay, so this is already in one fraction or one radicand, so what I want to do is we're going to go back to when we did our square roots at the beginning of the year. We're going to take our 27 and we're going to factor tree it. So 27 is 3 times 9 and 9 is 3 times 3. This 3 means I want groups of 3. So I need to see at least 3 of the same thing. So I have 1, 2, 3 threes. Because I have a complete set of 3, I can pull that 3 outside the radicand. We're going to do the same thing with that x to the 6th. I have x times x times x times x times x times x. So I have one group of 3 and one group of 3. So how many groups do I have? I have x squared. And this is our answer. If anything was left over, we would leave it inside just like we did with our square roots. Let's try this one. Okay. We have 16, which is 4 times 4. 4 breaks down to 2 and 2. This time I need a group of 4. So I've got 4 2's. So my 2 is coming out. I have no 2's left over, so no 2's left on the inside. Now that says I have 4 x's, right? And that's only one group of 4, so just 2x is my answer. Now, when I divide, let's first break it up into 2 separate things. So I'm going to put cubed root of x cubed over the cubed root of 7. Those two things say the exact same thing. But I need to remember to rationalize the denominator. I cannot have a square root, a cube root, any square root sign, any radical sign in the bottom. So what I have to do is I need to take this top and bottom by the cubed root again, but it's got to be this number, 7, and I've got 1 7 here. I need to count to 3. So if I've got 1, I need 2 more. So this 1 that we don't see plus that 2, so 1 plus 2 equals this 3 on the shelf. If I do it to the bottom, I've got to do it to the top. So when I do this, that's 7 cubed down here. So cubed root of 7 cubed. And on top, I have the cubed root of x cubed times the cubed root of, and 7 squared is 49. Okay, because these 3's match, all of this goes away. And on the bottom, we're just left with 7. Same thing with the x. These 3's go away. So I've got the x on the outside, but this can't be simplified, so we're going to leave it just like this. So this is our answer. Let's try another one with a different index. So I need to do the 4th root. So let's first break it up. I have a 1 right here. I need how many more to get to 4? Well, 1 plus 3 equals 4, right? So I need to take this times, put the 4 and the 3, but I need 3 more, so a little 3 here. 4, 3, and another little 3. Because I'm doing this, I've got 1 plus 3. That makes 4. So 4, 3 to the little 4 is on bottom, and on top I have my 4th root of x to the 8th times my 4th root of 3 cubed. So I need to simplify this. What I can do is I can either break up that 8 like I did up here and do 8 x's and figure out how many groups of 4 that is, or essentially you're just dividing. So 8 divided by 4 is 2, so that's an x squared. And then 4, this up here should never be able to be simplified. So 4 as the index, and then 3 cubed. 3 times 3 times 3 is 27. Over, and remember these 4's end up canceling, so that's just a 3 down here. Now, when we multiply, if our index is the same, so the 3 and the 3, we can just do whatever it says on the inside. So I'm going to keep that little 3 on the index. X to the 7th times x squared, remember we add our exponents. So that's something you need to remember. 7 plus 2 is 9. But I need to simplify that. So I can either draw my 9x's out, or I can just divide. So 9 divided by 3 is 3. So this is just x cubed. Let's try another one. Both of my indexes are 3. So 3 stays on the little shelf, the index. 9 times 3 is 27. X times x squared is x cubed. And now I need to simplify. We did 27 earlier, but I'll do it again. 3 times 9, 3 times 3. There's one set of 3's. So the 3 comes out. 3 divided by 3 is 1, so just x. So 3x is our answer for this problem. Try these two on your own.